All right, so we're going to start in on our first new concept for the spring semester, and we're starting with special segments in triangles. So there are going to be 4 types of special segments we're going to focus on, and I'm going to list those 4 out for you now. The first one is called a median. The second is a perpendicular bisector. The third is an altitude. And the fourth and final one that we're going to cover is called an angle bisector. So the first one we're going to talk about is a vertex. So a vertex, we have talked about it before. It has a little bit of a different meaning here, not far off, but it's a little more specific. It is the point where 2 sides of a triangle meet. So it's one of those 3 points, the sharp edges, the corners, if you want to call them, something like that. The next one is the midpoint, and we did hit this hard in the fall semester, and this is just that middle point. On a segment, though, the midpoint does create 2 equal parts, so keep that in mind as we're moving forward. So that does bring us now to segment, which is a line with 2 endpoints, and in the case of triangles, each side of a triangle is a different segment. So this next one is perpendicular, and we talked about parallel and perpendicular lines, their slopes. We're not necessarily talking about that here. With perpendicular, what I need you to know is that it's a straight line at an angle of 90 degrees or that it's a right angle. You'll see what I mean in the pictures when they come up. And then the last one we're going to cover for right now is bisects or bisector. When you hear this, when you see this, you automatically need to think about 2 equal parts. Something's cut in half. If it's a bisector, it cuts whatever it is in half. All right, so we're actually going to get into the special segments now. We're going to start off with median. So a median is a segment that connects a vertex of a triangle to the midpoint of the opposite side. I'm now going to give you a drawing with everything labeled so you can kind of see what that means. So we have triangle ABC here. So what our median would be is we start at a vertex. I'm going to start at point A, and that median drops down and connects our vertex to the opposite side, but when it does drop down and connect, it makes 2 equal parts. So I have this part from C to D, and then my second part is from D to B, and with medians, they're equal to each other. So I'm going to go ahead and label some of this stuff that we just drew. The first one, remember, this point at the top, that was my vertex that I started at. I dropped down to point D. Since it is in the middle, I'm going to call that my midpoint. And then remember, I have this line, well, it's a segment, and it is segment AD, and that is what our median is. So I'm calling that my median. So I'm going to go ahead and do 2 examples with you with some numbers. So I have your drawing here. I'm about to put the words that describes everything, but I have triangle YXZ here, and that segment XA is our median. So I tell you here XA is a median, which you already talked about, for triangle YXZ. I also now tell you if YA is 4, so I'm going to draw that here, from Y all the way to A is 4. I want you to find AZ, so that's the second part, from A to Z. I don't know what that is. And I also want you to find from Y to Z. So this is where it's really important for you to know those definitions. Remember, I told you the median connects a vertex of the triangle to the midpoint of the opposite side. It cuts that opposite side in half. So I have 2 equal parts, which is why I have these tick marks here. So I know that from Y to A is 4. I also know that from A to Z is also 4. So I know that YA is 4. That was given in our problem. I now know that AZ is also 4. I need to find from Y to Z, and I have both parts. So all you're going to do is you're going to add them together. 4 plus 4 tells us that YZ is 8. So this was an example where I gave you the part, and you had to find the whole. So here's your next example. I tell you that BD is a median, and it's shown there by those 2 equal parts, for triangle ABC. So if AC is 12, I want you to find AD and DC. So the first thing I'm going to do is label what I know. I know from A all the way to C is 12. And remember, I have two equal parts. So there's two ways to do this. You can think about what you add to itself to get 12. Or if you just take 12 and divide it by 2 because there's two equal parts, it's going to give you what you need. So if I take 12 and divide it by 2, I know that these two parts should each both be 6. So I know that AC is 12 because that was given to me. And I now know that AD is 6 and DC is also 6. We're going to move on to our second special segment, which is a perpendicular bisector. So a perpendicular bisector is a line segment or array that divides a segment, which remember we're calling a side, into two equal parts and is perpendicular to the segment or side. So remember, I told you perpendicular means that it makes that right angle, and we'll show that on the drawing. So I have triangle ABC here. Now I'm drawing in this ray that intersects our triangle at point D. Because it is a perpendicular bisector, remember, right angles are created. So that's what that little box means. And it's a bisector, meaning it cuts whatever it comes in contact with in half. It comes in contact with that side, so it's going to cut this whole AC in half, meaning we now have two equal parts again. So remember, we're referring to this ray as our perpendicular bisector. And then you also need to remember that we just created, with it being perpendicular, right angles. And since it is a line, remember that's equal to 180. There's one right angle, but there's also the one on the left as well. It's two right angles technically. So I just wanted to give you another drawing. You have triangle ABC here. This time though, that perpendicular bisector is coming through the vertex, which is B. You still have the right angle, and then you still have the two equal parts. It's just another drawing. Alright, so we're going to go ahead and get into our examples for perpendicular bisector. Alright, so I'm telling you here that ZA is a perpendicular bisector for triangle XYZ. I'm telling you if XA is 3, I want you to find AY, XY, and finally the measure of angle ZAY. So like usual, I'm going to go ahead and label what I know. I tell you here that XA is 3. I also tell you this is a perpendicular bisector. So remember, whatever it comes in contact with, it bisects. So it bisects the whole side XY into two equal parts. With that being said, if I know that XA is 3, I also know that AY is 3. I need to find XY, so all the way from X to Y. I know the two parts are 3, so I'm going to add those together, and 3 plus 3 gives me 6. So I found two of the three things I needed to find. From the problem, I know that XA is 3. I know that AY, its other part, is also 3. And I know the whole XY is equal to 6. The last thing I need to do is find the measure of angle ZAY. So remember, when we're naming angles, we can name them with 3 points, and we just follow in that order. So I'm going to highlight it in red. So I start at Z, I go to A, and finally to Y. So I'm looking at this angle right here, this ZAY. This is where our perpendicular bisector intersects the other side. And the other side has a 90-degree angle. And remember, in our drawings and the definition I gave you, I told you it ends up being two 90-degree angles. So I know by default, since it is a perpendicular bisector, that the measure of angle ZAY is also 90 degrees. So in this example, I'm telling you that BD is a perpendicular bisector for triangle ABC. If AC is equal to 8, I want you to find AD. So I'm going to label the information I know. I know that from A all the way to C, which is AC, is equal to 8. Now I know this is the whole, and remember our perpendicular bisector cuts that segment, that side, into two equal parts, it cuts it in half. So we're going to do the same thing with the number we're given. We're going to cut it in half or divide by 2. So 8 divided by 2 gives me 4. So I know from the problem that AC is equal to 8. And I now know that AD is equal to 4. If I ask for DC, you could also find that, which is what I already labeled. And that one's also 4 as well. So the third one we're talking about is the altitude. So an altitude is a segment that connects the vertex of a triangle to the opposite side so that it is perpendicular to that side. So here's your general drawing. Up at the top we have the vertex that the altitude goes through. And then remember right here, I drew it already, but I'll highlight it in yellow. That's a right angle that the altitude makes. So just for labeling purposes, remember that middle segment is your altitude. It's important to know here, though, that the altitude does not cut that side of the triangle in half. In the example I'm going to show you, it's just to show that purposes, just so you can remember that. So here's your example, the drawing of it. So this is a problem I'm giving you. I'm telling you that BD is an altitude. So remember, it goes through the vertex, intersects the other side at a right angle, but doesn't necessarily mean it cuts it in half. For triangle ABC, I want you to find DC, so I'm going to label that right now. I don't know what it is. I'm looking for D to C. If AD is 2, so this segment is 2, and AC from A all the way to C is equal to 5. The easiest way to look at this, I know the whole is 5. I know one of the parts is 2. I can subtract them, and when I do, I end up with DC being 3. So I know from the problem that AD is 2. I just found that DC is 3. And also from the problem I was given AC, which is 5. So the fourth and final special segment we're going to talk about today is the angle bisector. So an angle bisector is a line, a segment, or a ray that divides an angle into two equal parts. It has that word bisector in the name, so whenever you see that, you should always associate something being cut in half. So for your drawing, we have triangle ABC. And I now have this ray going through the point at A. That's going to be an angle bisector. It's cutting that big angle in half. So I'm going to mark it with angle markings, each with just one, telling me that those angles are equal to each other. So we're going to go ahead and get into the examples. This is the drawing for your first one. So I'm telling you here that YO is an angle bisector, and if angle XYO is equal to 36 degrees, I want you to find the measure of OYZ and the measure of angle XYZ. So I'm going to label what I know. I know that XYO, which remember we go X to Y to O, that tells me it's this angle right here, is 36 degrees. I also know that that line YO, or that ray YO, is an angle bisector. It cut that bigger angle in half, meaning this right side is also the same as the left. So I also know this small angle is 36 degrees as well. So I'm going to list out what I know already. I know angle XYO is 36. I know angle OYZ is also 36. And the last thing I'm asking you to find is angle XYZ, the big angle. I know what the two parts are. In order to find the whole, I just add them together. So 36 plus 36 gives me 72. So I know that angle XYZ is equal to 72 degrees. So for your second example, I tell you that MO is an angle bisector. And if angle LMN is equal to 80 degrees, I want you to find the measure of LMO and the measure of NMO. So we're going to look at what information we're given first. I know LMN. This angle right here is equal to 80 degrees. I know that MO is an angle bisector, so it took that big angle of 80 and actually cut it into two smaller equal angles. So remember that bisector cuts something in half. To find the smaller angles, you're going to cut the large one in half. 80 cut in half, or 80 divided by 2, tells me that these two small angles are each 40 degrees. So I know that angle LMN is equal to 80 degrees, and that's because it was given. I also know that angle LMO is equal to 40 degrees. Remember, we took that big angle and cut it in half. And I also know that NMO is also 40 degrees. So you do have some practice problems that go through the 4 different types of special segments. Remember that these are attached to that Google slide as well, so you're just going to follow that link. It'll take you to the PDF. Once you're done, make sure you have the correct heading on your paper, and then you'll turn in a PDF file of those practice problems to the actual module assignment on Google Classroom.